Atmospheric sciences is the study of Earth's atmosphere, ranging from day-to-day weather patterns to decades-long climate studies. At the University of Illinois, a team of devoted students is getting hands-on experience through a program called the Propagation, Evolution, and Rotation in Linear Storms, or PERiLS for short. Through PERiLS, a 2-year field campaign, students study weather as it happens and where it happens, with the goal of learning more about how severe storms develop.
We're really hoping to learn more about the physical processes that cause tornadogenesis.
It's really focused on understanding a particular type of tornado that's unique to the Midwest and the Southeast United States, and these are called QLCS tornadoes. These are tornadoes that form oftentimes at night with very little warning. The kind of research we're doing is really important because we're actually improving the predictability of those things all the way from days down to minutes so that people can have adequate warning. We've mobilized a group of about 18 students to help us participate in this project. And the whole experience is really rewarding for the students because they get to see the whole project through from end to end.
As part of the project, students collect and analyze data during several IOPs, or intensive observing periods. These IOPs would be planned in the days and weeks leading up to potential severe weather, with the team meeting to discuss the constantly evolving forecasts and what specific locations to focus on. The final decisions would be made just days before the storms.
That's when it starts to come down to the logistics of everything, of who's gonna come, who's gonna be doing what, and how many people we're gonna need for, depending on the scope of the event.
The third mission, we call IOP3, was also the farthest. For us, we drove from Urbana to Montgomery, Alabama, which was quite a drive for us. As part of their role in this field campaign, the students helped drive radar trucks. They helped put together radars and then disassemble them after our operations. And then helped deploy weather instrumentation that we called pods. They launched weather balloons.
Our students are a key part of this project, and we have a lot of seats. We need people to drive, to launch balloons, to operate radars.
I was part of the sounding truck, so I was responsible for helping launch weather balloons. There were a line of storms that we could collect data on. We would set up somewhere away from power lines and trees. We would turn on the sensor, make sure that it was talking to the computer correctly, and then we would fill up the weather balloon with the helium. Every hour before, during, and then after the passage of the storms, we would launch weather balloons, and then we would see the data being read into the computer.
I specifically got to work with the COW, or the C-band on wheels radar, and I was able to help operate this during PERiLS. Unlike some of the other mobile radars that we have, the antenna actually has to be assembled before we can use it. We can't just drive with the antenna because the antenna is so large. And just learning that whole entire process of how to assemble the radar, how to operate it, that was one of my favorite parts of the campaign.
Yeah, we are quite attenuated about azimuth.
For the Montgomery IOP, my role is essentially as a data collector, but also I've assisted Jeff Trapp as the PI for the Mesonet team and making decisions on where to put the trucks and where we should put the instruments. And then also discussing the relative transects, so that being how our pattern of driving to and from the storms and what is the relevant data we should collect that answers the science question.
Keep going this direction, we're going to be driving through the long leg of it.
PERiLS is a multi-institutional field campaign led by University of Illinois students and faculty. Other institutes involved in the project include North Carolina State University, the National Severe Storms Laboratory, the National Science Foundation, and the National Oceanographic and Atmospheric Administration.
What we're really looking for are these large coordinated data sets. We want radars, we want weather balloons, we want surface stations, and we want to be able to integrate all of that information into a complete story of what the atmosphere is doing when it does or doesn't make a tornado. Having all of these people engaged who are experts with these different instruments really is what makes that happen.
So having people with different experiences, different backgrounds, different interests can help create like a better story with the data that you collect.
There was only one mesovortex that overlapped with a pod in IOP2, but the wind speed...
In a lot of sciences like chemistry, you do your science in a laboratory. You can control experiments and test tubes. Whereas, of course, in atmospheric sciences, the laboratory is the atmosphere outside. And so students love to get out, experience the weather that they're studying, and actually see some of the phenomena like tornadoes or hurricanes that they learn about in textbooks. So it's just a natural laboratory for them.
Field experience is very important because you can only learn so much in the classroom. You can only learn so much by reading words and like looking at figures, but when you actually get out there and like you can feel the wind change, you can feel the change in temperature, and then everything kind of makes sense and you can see things more in like a 3D scale, which is what the atmosphere is. It's not 2D like what you look like on maps and textbooks and stuff.
And just, I don't know, being out in the field and seeing, you know, the winds start to kick up, like the storms start to roll in, it's just very invigorating.
I think they like getting out, they like seeing the storms, but I also think this is really valuable experience that ultimately will lead to the next generation of researchers.
The Atmospheric Sciences program at Illinois is unique in the equipment it has, as well as field research opportunities like PERiLS, that's provided to both graduate and undergraduate students.
Everyone okay with that? And that's based on this. We could go through other examples. Then maybe it's going to be 12 or maybe it's going to be 9 or something like that. We're basically coming up with a rough number.
And depending on what they want to do afterwards, they can have a huge item on the resume that they were field scientists and studied cutting-edge weather phenomena with state-of-the-art equipment.
At some point they could point to the data that we collected and say that they contributed to this better understanding which is helping to save lives.
Going out in the field, really I think it's fun. It's something that I look back on and I'm like, yeah, I would do that 100 times over and I would never get tired of it.